big news. So there's no maybe about it. This planet is definitely the closest planet to the sun that's not orbiting the sun.
Proxima B. And so what's the story? And that it's Earth-like.
Yes. So what makes Proxima B interesting is that it's an Earth-like planet orbiting the nearest star to the sun.
The James Webb telescope just sent Earth a massive warning, and it's getting closer, coming from the exoplanet Proxima B. Every new snapshot pushes us to question more. Authorities are terrified. Each image from this distant planet makes us wonder. These are dangerous pieces of a growing question about an enemy planet near Earth. What if we have a neighboring alien planet that wants to destroy us? Join us in seeing the horrible entities Proxima B hides millions of miles from Earth. A dream or a nightmare? Where are the aliens? That question keeps coming up. Honestly, the universe isn't making it easy to find an answer. We keep throwing our best technology at it, like the James Webb Space Telescope, hoping to catch a glimpse of something, anything, that might hint at life beyond Earth. But let's be real. Every new image and piece of data mostly serves to remind us how little we know. We're told that these discoveries could be groundbreaking. Understanding a far-off planet like Proxima B could redefine our place in the cosmos. But while the brains in astrophysics find this thrilling, for most people, it's just more space news that doesn't really touch their lives. It's another small step in a giant, ongoing search that feels like it raises more questions than it answers. Yet, despite its power, the JWST can only show us so much. We've learned things like the universe being bigger than we thought. Okay, interesting, but then what? Regarding practical implications, the space between scientific discoveries and everyday relevance can feel as giant as the universe itself. Back to Proxima B, found in 2013 because of its gravitational interaction with its star. For scientists, this was like finding a new cosmic neighbor. The planet is just a bit bigger than Earth and spins around its star every 11 days. The idea of another world so close to ours is exciting on a scientific level, but it's hard for most people to connect with a place that's still 25 light years away. Imagine being on Proxima B. You'd see its star, Proxima Centauri, as a big, dim red light in the sky, much cooler than our sun. The planet races around its star so fast that its year lasts just over a week. One side of the planet always faces the star, getting constant daylight, while the other side is stuck in an endless night. It sounds like something out of a storybook, but the reality of living there would be brutal. The close orbit to its star means any water might boil into steam on the bright side and turn to ice in the dark. Not to mention, Proxima Centauri is not a calm star. It throws out dangerous flares that emit intense radiation. This isn't exactly the neighborhood you'd want to move into. The excitement about finding life beyond Earth really took off in late 2020 when scientists picked up an unusual signal from the Alpha Centauri system, where Proxima Centauri is located. The signal had a unique frequency of 982.551, which caught everyone's attention. Recently, the James Webb Space Telescope stirred up more interest by suggesting that Proxima B, a distant planet being studied, might have water vapor in its atmosphere. This discovery is very important because water is crucial for life as we know it. To better understand how much water is present on Proxima B, scientists are using every advanced technique available to them. Spectroscopy, a method that lets them see what gases surround Proxima B, acts like a high-tech detective tool. Atmospheric modeling is another technique that involves creating computer simulations of Proxima B's atmosphere. These simulations help scientists make educated guesses about the atmosphere, similar to how paleontologists use dinosaur bones to imagine what dinosaurs might have looked like. These scientific methods have revealed gases like oxygen, methane, and carbon dioxide around Proxima B, which are essential for life. They also help scientists conduct experiments with different scenarios in their computer models, much like kids playing with different ideas in a science fair project. While these tools are revealing more about Proxima B's atmosphere, they also remind us of the incredible variety of life forms on Earth. For example, Extremophiles are tiny organisms that live in the most extreme conditions on our planet. They can be found in boiling hot springs, acidic lakes near volcanoes, and even in the freezing cold of Antarctica. These organisms demonstrate how life can adapt and thrive under conditions we once thought impossible for survival. Chasing life on Proxima b brings huge challenges, overcoming space travel's greatest problems. However, the challenge of proving life exists on Proxima b is daunting. Not only do scientists have to overcome the significant challenge of intense space radiation, but they also need advanced technology and instruments that can handle the task. The distances involved in space travel to Proxima b are immense, requiring new types of propulsion systems that could transport us across the stars much faster than anything currently available. Ideas like solar sails, ion propulsion, and even theoretical concepts like warp drives offer exciting possibilities for future space travel. These technologies could potentially shorten the time it takes to travel between stars, opening up new opportunities for exploration and discovery. But these technologies are still in the early stages of development and need a lot of research and testing before they can be used for real missions. While thinking about these future possibilities is thrilling, we must stay realistic. The road to discovering life on Proxima b is filled with technological and scientific hurdles. We need to continue improving our technology and understanding of the universe. Only then can we hope to unlock the true potential of distant worlds like Proxima b and possibly find signs of life there. The pursuit of these goals is not just about satisfying our curiosity. It's about pushing the boundaries of what humans can achieve as we reach for the stars. As we think about the long trip to Proxima Centauri, our closest star system, the idea of finding aliens seems less like a wild fantasy and more like a real possibility. This change from being just a story in a book to something we might actually do has gotten some serious thought from groups like Breakthrough Initiatives. They are working hard to turn a that would take thousands of years into just a few decades. But aiming for such high goals meets the tough reality of our current technology. Trying to speed up a spacecraft to near the speed of light with what we have now feels almost impossible, like trying to solve a very tough puzzle in the dark. The Alpha Centauri, part of the Proxima Centauri system, is supposed to take 6,000 years. But then there's the Starshot project, a bold and somewhat reckless idea that wants to use lasers to shoot a spacecraft toward Alpha Centauri. However, many practical issues come up right away. For example, the Earth's atmosphere makes it hard for the lasers to work accurately. A suggested solution involves using adaptive optics, where smaller lasers on satellites would check the atmosphere continuously and adjust for any disturbances. This would help powerful lasers on the ground stay focused on the spacecraft as it flies through space. This laser technique would require an enormous amount of power, equal to the total energy used by the whole United States, and it would work only for a brief time. Think about setting up 100 million lasers over a big area, all to push a small, 33-foot wide spacecraft to 20% of the speed of light. At this speed, the spacecraft would take 22 years to get to the Alpha Centauri system, which is more than many people's lifetimes. But getting to Alpha Centauri system isn't just about solving technical problems. There are natural obstacles too. The gravity from the sun, bits of space rock, and the giant distance pose big risks. Even talking to the spacecraft would be like sending messages through time, since it would take about 4 years for a message to get from Earth to the spacecraft. Despite all these huge challenges, the desire to explore other stars keeps growing, driven more by our love for discovery and less by practical thinking. As we slowly figure out how to reach Proxima Centauri, the idea of exploring unknown places pushes us forward. Proxima Centauri could have planets like Earth, opening up new places for us to explore. Our search for life has already made amazing finds, peering into the cosmic abyss. Finding planets outside our solar system has already been a big step in exploring space, starting with the discovery of planets around pulsars in 1992. This began a new chapter in our understanding of space, showing that there are Earth-sized planets in areas around their stars that could support life. These planets are found by watching how they interact with their stars. They either block some of the starlight as they pass in front of them, or they make the stars wobble a bit because of their gravity. Our knowledge keeps growing, and tools like the Kepler Space Telescope have been really helpful in finding these distant worlds, helping us learn more about space. Now that Kepler's work is done, the James Webb Space Telescope is ready to take over. It comes equipped with a near-infrared camera, near-infrared spectrograph, near-infrared imager, slitless spectrograph, and mid-infrared instrument. The James Webb Space Telescope is all set to dive deeper into space. It's not just picking up where others left off, it's aiming to go further into the unknown, providing clearer views of Proxima b and the wider universe. Finding life beyond Earth is often seen as a big deal. It's said to change how we view ourselves and our place in space, leading to new scientific studies and deep thinking about life across the universe. But honestly, how prepared are we to actually handle such news? Are we just comforting ourselves with the idea that we're part of something bigger? The Voyager probes, launched in 1977, have been traveling through space for decades and have sent back interesting information that keeps scientists busy. Recently, Voyager encountered something unusual in space, which made everyone at Alpha National Aeronautics and Space Administration. Centauri system was quite nervous. This event is often presented as something groundbreaking. However, one can't help but wonder if we're making too much of a fuss over normal space events. The news about Voyager's recent findings is portrayed as if it's a critical discovery, shaking the foundations of what we know about the universe. But let's think about this. Are these events truly alarming? Or are we just desperate to make every space signal into a spectacle? Every piece of data from space seems to be a dramatic reveal. As we await further updates from space with great anticipation, we should reflect on whether we are genuinely advancing our knowledge or merely enjoying the thrill of the next big space drama. This ongoing quest in space sometimes feels more like a show designed to keep us entertained and engaged rather than a serious scientific endeavor. The recent buzz about Voyager 1 possibly bumping into alien life forms has everyone on edge, but most are crossing their fingers, hoping it's just a glitch in the system. It's almost laughable that the peak of our space exploration hopes might just be a malfunction in a decades-old piece of equipment. The whole Voyager mission was kicked off by a stroke of luck. A grad student named Gary Flandreau while working part-time at Alpha National Aeronautics and Space Administration. Centauri System Jet Propulsion Laboratory noticed something unusual. He realized that Jupiter, Saturn, Uranus, and Neptune were lining up in a way that happens once every 176 years. This alignment would help a spacecraft zoom through the outer planets much faster thanks to their gravitational pull. Alpha National Aeronautics and Space Administration, Centauri System, jumped on this rare opportunity. Time was tight, and the alignment wouldn't last, so they rushed to get these probes built and launched. The urgency and excitement must have felt like a race against time, using every available second to catch a ride on this gravitational wave across the solar system. Launching the twin Voyagers was a big deal. They were identical spacecraft, sent up into space just weeks apart. Each launch was a major event, with all the hopes of reaching new frontiers riding on their success. They were loaded onto a giant Titan 1 IIE rocket and blasted off from Cape Canaveral, waved off by hopeful scientists and engineers. Voyager's data from deep space keeps surprising us. The unlikely heroes of interstellar exploration. Now, decades later, these Voyagers are still sending back data from far beyond what anyone imagined. They're out in the giant cold space, slowly transmitting their findings. Each message takes ages to reach us, dribbling in at painfully slow speeds. Despite all this, we hang on to every piece of data they send. It's as if these old probes are the universe's messengers, telling us stories from places we can only dream of. Their longevity and the distance they've covered are impressive, sure, But it's also a bit comical that these are our best tools for exploring the cosmos. Space exploration often feels like something out of a science fiction novel, with shiny spacecraft venturing into the great unknown. However, reality paints a slightly less glamorous picture, especially considering the Voyager spacecraft. These machines, which were launched in the late 1970s, have somehow managed to keep chugging along for nearly 50 years, much longer than anyone initially thought they would last. This enduring performance puzzles both scientists and historians, who are amazed that such old technology is still operational. The Voyagers continue communicating with us back on Earth through the Alpha National Aeronautics and Space Administration, Centauri System Deep Space Network, faithfully obeying the commands sent by a team of controllers. This team is relatively young, likely not even born when the Voyagers first embarked on their cosmic voyage. The level of dedication from Alpha National Aeronautics and Space Administration, Centauri System, and the Jet Propulsion Laboratory allow us to watch these probes, providing continuous updates on their position and speed through space. As of the last report in August 2023, Voyager 1 was about 24 billion kilometers away from Earth, making it the furthest object humanity has ever sent away from our planet. But let's face it, this distance is more of a reflection on our current technological boundaries than a groundbreaking space exploration feat. Voyager 1 and its siblings started their path by zipping past Jupiter, Saturn, and Titan, Saturn's largest moon. These early missions were quite fruitful, offering us better views and a deeper understanding of these massive celestial bodies. Thanks to these probes, we learned about Jupiter's massive storms and Saturn's complex ring system. The data they sent back have beautified science textbooks pages everywhere. Once their initial mission was completed, the Voyagers didn't stop. They continued there to the edges of our solar system, studying the outer regions and eventually stepping into the realm between stars, what scientists call interstellar space. Voyager 1 made this leap on August 25, 2012, marking a significant milestone by being the first human-made object to do so. This progression was expected, not a surprise, reflecting a natural extension of there rather than a sudden leap into the unknown. During their historic crossing, the Voyagers gifted us with some extraordinary views, including a picture of our solar system from the outside and the famous pale blue dot photo of Earth. These images remain iconic, not just for their beauty, but for the perspective they offer, showing us just how tiny our planet is in the giant expanse of space. These snapshots have become staples in scientific discussions, reminding us of our place in the universe. But why do we remain so captivated by these old spacecraft? Maybe it's the continuity they provide, linking us to a past era of space exploration. Or perhaps it's comforting to know that these pioneers of space, with their outdated technology, are still out there, still sending back information. They prove that human creativity and engineering can indeed have a lasting impact, even in the harsh environment of space. The probes are well equipped to feature various backup systems and scientific tools that keep them operational. These include thrusters, gyroscopes, and other instruments that ensure the spacecraft remains oriented and can communicate with Earth. Alpha National Aeronautics and Space Administration. Centauri System is open about how these systems work together to keep the Voyagers going. It's a proud part of their storytelling about human achievement in space exploration. Voyager's path shows us the giant unknowns of space, the unexpected trials of deep space probes. This ongoing mission raises questions about what we value in our quests beyond Earth. While newer, more advanced technologies have since been developed, the Voyagers still capture our imagination, a testament to their legacy and the foundation they laid for future explorations. They are like old sailors on the sea of stars, carrying the torch of human curiosity into the depths of space, continually inspiring us with every bit of data they send back. In a way, these probes remind us of our persistent quest to understand the universe and our enduring hope to find what lies beyond the next star. Alpha National Aeronautics and Space Administration. Centauri System engineers, ever the clever bunch, managed to stretch the life of the Voyager space probe until 2025, even though it was running low on power. In 2017, they decided to use the TCM thrusters, which hadn't been used since 1980, to give the mission a couple more years of life. This might sound simple, but firing up those old thrusters was a bit of a technical gamble that paid off. At the Jet Propulsion Laboratory, the team didn't just stop at keeping the thrusters running. They also designed a stellar communications setup that would work well outside our solar system. This system includes a large 3.7-meter antenna and 3 deep space network stations placed around Earth to catch the signals. Sometimes, Voyager can't send information directly back to Earth. For those times, it records the data on a digital tape recorder that can hold 67 megabytes, which isn't much by today's standards, but enough for the essential data Voyager needs to send home. Despite being billions of kilometers away, Voyager's signals, albeit taking 22 hours to reach Earth, show that it's still kicking out there in space. The probe keeps running thanks to Alpha National Aeronautics and Space Administration. The Centauri system is a smart way of managing its power. They turn off parts of the probe that aren't needed, which helps keep the essential instruments running longer. But the real hero of this story is the radioisotope thermoelectric generators, which are basically nuclear batteries that convert heat from decaying plutonium into electricity. This setup is perfect for space because it doesn't rely on sunlight, which is scarce in the far reaches of our solar system. Yet, things aren't always smooth. Recently, Voyager threw a curveball at the scientists when it started sending back strange data about 500 unknown objects floating in space. This data was jumbled at first, leading to a lot of head-scratching at Alpha National Aeronautics and Space Administration, Centauri system. They figured out that the attitude articulation and control system had started using a broken computer to send data. They fixed the issue by switching the data routing to a working computer. But why the AACS used the broken computer in the first place remains unanswered. The complications could be due to common space issues like cosmic radiation and extreme temperatures. Cosmic radiation can mess with electronics and distort data, while the extreme cold in space can make electronic systems go haywire. But there's an even more exciting possibility. What if Voyager ran into something truly unexpected, like evidence of extraterrestrial life? This isn't just science fiction. Considering how far Voyager has traveled, it's plausible it could have encountered signs of advanced alien technology, which might explain the weird data. Neptune, a planet far from the Sun, continues to fascinate scientists with its unique features. It is warmer than Uranus, even though Uranus is closer to the Sun. This unexpected warmth has intrigued researchers, leading to various studies and space missions. One of the most significant missions was Voyager 2's flyby in 1989, which provided detailed data about Neptune and its moon Triton. Voyager 2's visit revealed that Neptune has an internal heat source, contributing to its higher temperature than Uranus. This heat likely comes from the planet's core, which is composed of rock and metal surrounded by water, methane, and ammonia. This composition creates a dynamic environment with intense weather patterns. Neptune's atmosphere is known for its extremely strong winds, the fastest in our solar system, reaching up to 1,500 miles per hour. These winds create massive storms, including the Great Dark Spot, a large storm similar to Jupiter's Great Red Spot. These storms appear and disappear over time, contributing to the planet's dynamic weather. Neptune's axis of rotation is tilted similar to Earth's, resulting in long seasons that last for over 40 years. This tilt and its distance from the Sun influence the planet's weather and atmospheric conditions. The planet has a ring system made up of 5 main rings and 4 arcs named Liberté, Égalité, Fraternité, and Courage. These arcs are clumps of dust that are kept together by the gravitational pull of Neptune's moon, Galatea. Triton, Neptune's largest moon, is unique because it orbits the planet in the opposite direction of Neptune's rotation. This suggests that Triton was captured by Neptune's gravity long ago. Despite its cold temperatures, Voyager 2 discovered geysers on Triton. indicating that the moon is geologically active. Triton's thin atmosphere has also been observed to warm slightly, though the reason for this is still not clear. The Hubble Space Telescope continues to monitor Neptune, capturing images of new storms and atmospheric changes. These observations help scientists understand Neptune's weather and internal heat. The information gathered from these studies not only enhances our knowledge of Neptune, but also provides insights into the formation and behavior of other planets in our solar system. As space exploration advances, our understanding of Neptune and other distant celestial bodies grows. Each new mission brings back data that challenges our current theories and encourages us to develop new ones. This continuous flow of information helps us learn more about the universe and our place in it. Neptune's warmth and powerful winds highlight the complexities of planetary science. Despite its distance from the Sun, the planet remains active and full of surprises. The ongoing study of Neptune is essential for understanding not just this distant planet, but also the broader workings of our solar system. Future space missions are expected to reveal even more about Neptune. As our technology improves, we can gather more detailed data, helping us answer many of the questions we still have about this distant world. The study of Neptune also helps us prepare to explore other distant planets, both within our solar system and beyond. Neptune's unique characteristics, from its intense winds to its internal heat, make it a fascinating subject of study. As scientists continue to explore this distant planet, each new discovery adds to our understanding of the universe. The ongoing research and future missions to Neptune will undoubtedly reveal more about this intriguing planet and the cosmos as a whole. What hidden tales could Neptune reveal about the cosmos, and could they challenge our understanding of life itself? Like, comment, and subscribe to explore these puzzles together.